The Arctic is not just a place, it's a graveyard for ships. In this frozen wilderness, ice behaves like solid rock, over 12 feet thick. Ordinary steel hulls are crushed like soda cans under the relentless pressure, but humans have engineered a titan designed to survive where others perish, the icebreaker. This is more than a vessel, it's a floating demolition machine. Today, we witness the birth of this ocean conqueror, a project costing billions and taking years of extreme engineering to complete.
The journey begins in the fire. Standard shipbuilding steel becomes brittle like glass in extreme cold, snapping under the slightest impact. To solve this, scientists created Arctic-grade steel. In these giant furnaces, the metal is heated to over 1,500 degrees. This is the birth of the ship's invincible armor, a material so tough it can withstand the impact of a skyscraper-sized iceberg without a single crack.
Precision is the difference between survival and disaster. Using computer-guided CNC plasma cutters, engineers slice through steel plates that are up to 15 inches thick. This isn't just cutting. It's a high-tech operation where lasers guide a plasma torch hotter than the surface of the sun. Every single piece is marked with a unique digital code. These plates are the bones of the giant, meticulously shaped to fit together into a structure that can survive thousands of tons of external pressure. One wrong cut could compromise the entire hull, so there is zero room for error.
An icebreaker is essentially two ships in one. This double hull architecture is a revolutionary safety feature. The outer hull takes the direct hits from the ice, while the inner hull remains protected. The 5-foot gap is filled with a dense grid of steel beams. If the outer skin is pierced, the inner fortress remains watertight. This layered defense is what makes the icebreaker the most unsinkable ship on the planet. The most critical part of an icebreaker is its bow. Unlike a traditional ship that cuts through water like a knife, an icebreaker is shaped like a giant reinforced spoon. This design isn't meant to cut the ice, it's meant to slide on top of it. Gravity then does the hard work, crushing the ice beneath. To achieve this complex curve, massive hydraulic presses apply millions of pounds of force to bend the thickest steel plates in the world. To join these massive plates, thousands of miles of welding are required. Human hands would take a lifetime, so giant robotic arms take over. They use a process called submerged arc welding to create atomic-level fusion. The heat is so intense that the two steel plates effectively become one solid piece. These seams are the strongest points of the ship. The robots work 24/7, guided by sensors that ensure every weld is deeper and stronger than the steel it connects. This isn't just welding, it's the creation of a seamless steel fortress.
In the Arctic, there is no good enough. After the robots finish, human inspectors step in. Every single weld is scanned using high-frequency ultrasound. These machines can see through 10 inches of solid steel. They look for flaws invisible to the naked eye. Even a defect the size of a pinhead is enough to reject a block. If a defect is found, the steel is cut out, melted down, and redone. This obsession with perfection is what keeps the ship alive in the crushing grip of the frozen sea.
Ever wonder how a titan of the sea is built? It starts with the world's biggest puzzle. These are mega blocks, prefabricated sections weighing as much as several airplanes, positioned with laser precision. When the final piece is set, the Titan's skeleton is complete. A masterpiece of human coordination and engineering. Now, you can build your own maritime marvel. A durable, easy-to-assemble model that brings this epic engineering to your home. Unleash your inner engineer. Build your own adventure, one block at a time. To crush ice several meters thick, you need more than just an engine. You need a powerhouse. This is where the heart of the beast is installed. These reactors or engines generate over 100,000 horsepower. enough to provide electricity to a medium-sized city. Lowering this 2,000-ton heart is a high-stakes operation. A single millimeter of misalignment could cause a mechanical disaster. Unsecured, this heart will beat for decades, providing the brute force necessary to push 200,000 tons of steel through solid, frozen barriers.
The propellers of an icebreaker are its primary weapons. Unlike standard bronze propellers, these are made from high-strength stainless steel to survive direct impacts with massive chunks of ice. The propeller shaft itself is reinforced with extra thick steel to prevent it from snapping under extreme torque. Each blade is designed to act as a grinder, pulverizing ice into slush as it rotates. The system converts raw engine power into the unstoppable forward thrust that defines the ship's mission.
Even the most powerful ships can get stuck in the Arctic's grip. To prevent this, engineers designed the healing system. Inside the hull, massive ballast tanks are connected by high-capacity pumps. If the ship gets wedged, these pumps can move hundreds of tons of water from one side to the other in seconds. This creates a violent rocking motion, causing the ship to sway and break the suction of the ice. It's like a giant wrestling its way out of a trap, using its own weight as a tool for freedom.
One of the biggest enemies of an icebreaker is friction. Ice can stick to the steel hull, slowing the ship down. To combat this, a specialized air bubbling system is installed. Thousands of tiny holes along the bottom of the hull pump out high-pressure air. These bubbles rise up, creating a layer of air and water between the ice and the ship's skin. This acts as a lubricant, reducing friction by up to 30%. It allows the ship to glide through the ice with less resistance, saving fuel and increasing the ship's braking efficiency.
Navigating a frozen ocean requires more than just a steering wheel. The bridge of an icebreaker is a high-tech command center. It features specialized ice radars that can distinguish between soft new ice and dangerous rock-hard multi-year ice. Thermal cameras and satellite links provide real-time data on ice flows miles away. The captain uses this information to find the path of least resistance. In this room, technology and human experience combine to guide the giants safely through the most treacherous waters on the planet.
This isn't just paint, it's a high-performance shield. Engineers apply a specialized low-friction epoxy coating to the entire hull. This coating is incredibly smooth, designed to make the ice slide away easily. It also protects the steel from the extreme corrosive effects of salt water and the constant scraping of ice. Applying this coating is a multi-week process that requires perfect temperature control. Without this slippery shield, the ship would lose its edge and consume significantly more energy to move through the frozen north.
After years of construction, the moment of truth arrives. The float out. Millions of gallons of water are pumped in. There is a tense silence as the 200,000-ton Titan begins to groan, lifting off its supports for the very first time. This is a crucial test of the ship's buoyancy and balance. For the engineers, seeing this mountain of steel float is the ultimate reward for their labor. Gates open, and the ship is towed out, ready for its final and most dangerous assignment.
The journey ends where it was always meant to. The Arctic. Here, the ship undergoes sea trials. It is pushed to its absolute limits, crashing into 12-foot thick ice at full speed. Every system, from the nuclear heart to the air bubbles, is tested against the brutal reality of the frozen north. As the ice shatters like glass under its weight, the mission is accomplished. The icebreaker has proven its dominance. It is a triumph of human engineering over the most hostile environment on Earth. opening the way for global trade and exploration.